In this video, we're going to talk about how to measure fuel pressure with special equipment like this on a port fuel injection car like this Toyota here. We'll talk about the setup, getting a reading, and of course, including how to safely depressurize the system. Let's start with what we're going to need to do this job. First, we need a special tool set that will allow us to connect a gauge to the fuel system. And so there are a variety of kits available like this one here. This happens to be a SnapOn Master Fuel Injection Test Kit. Most manufacturers today have gone to a quick release style fuel system fitting for their low pressure system. And so this kit aims to help adapt to all of these different varieties that manufacturers have. So most have gone to a quick release setup like this, where there is a plastic assembly that has a catch in it that's helping to lock the connection together. It usually has tabs or some mechanism to release it. And then internally it's got O-rings to help seal the fuel and keep it within. And so the trick here, the goal is for me to find a female and male connection point so that I can adapt this to my fuel system and put my gauge in series so that I can read the pressure that's flowing through that system. So before we get to the car, we're going to start by figuring out how we're going to depressurize the fuel system. This is important because I need to be able to release the pressure that's in that fuel line before I open it, so I can avoid that fuel spraying and possibly injuring me or creating a fire hazard. So I'm going to pick my Toyota RAV4 here. We're using all data today for our service information. I'm going to go to diagrams, and I've got two choices. I can do a non-OE or OE. I'm going to pick the non-OE version. It's a little bit better condensed. Powertrain management, engine controls. And here, right on the first page, scroll down. Here I've got my fuel pump. So they say fuel suction pump, which is in the fuel tank assembly. Real simple, right? It's got power, it's got ground. And so my goal is to disable this fuel pump. I want to disable the power that goes to the pump so that I can crank the engine, allow the injectors to relieve the fuel and fuel pressure that's in the system without being fed by this pump. And so my goal is to disable the current or the voltage going to that pump without disabling the ability for the car to crank or for the injectors to be fired. And so I've got to pay attention. If I go up here, I've got my C/OPN relay. I could potentially remove that relay if it's accessible. That relay on the right side, its control side, is fed by this ignition fuse. That would help disable my fuel pump as well. But if I pull that, you can see there's a splice here and there are two power wires right here. And if I follow those, they go back into the PCM where it says ignition switch. So that might inhibit the car's ability to crank, and that's gonna be an issue for what I'm trying to achieve. So if I draw back a little further, C/OPN is one of my options, pull that relay. But the action side or the current path for the pump right here on this yellow wire actually comes from the A/F relay, which is my air fuel sensor relay. And so if I pull that relay, I'm going to lose my air fuel sensor. That's going to create a trouble code. I've got to be aware of that because I'm going to need to clear it if I choose to go this route. But otherwise, I could also just pull this AF fuse. I'm going to lean toward that because here it is. It's in the engine room junction box. That's going to be more accessible than digging around under the dash. So let's go check there. So here at the car, I'm in the engine bay. This particular car has two junction boxes out in the engine bay. Service information told me on the left side, right? That's always driver perspective, so I'm gonna look right here. So here with the cover off, I can take a look and figure out where I need to be. I've got my A/F 20 amp fuse right here. That's the one that we identified. The alternative was a relay, but this one's gonna be pretty simple. So I'm gonna go ahead and pull this 20 amp right here. That should disable my fuel pump. Now we'll get back in the car, we'll go ahead and crank the car. We expect it to start and eventually stall, and then we're gonna crank it again to make sure we get as much fuel out of the system as possible. All right, so we pulled our fuse, we took power away from the fuel pump, we were able to crank it. This particular car did not start. Some vehicles will start on residual pressure that's in the system, some will not. There's some other variables too, depending on how long the car has sat, how well the check valve in the low pressure fuel pump holds pressure. All those variables are going to come together as to whether or not it starts, runs, and dies, or just cranks. But the end goal is that we wanted to take power away from that pump, and then use the injectors by cranking the car, have them open in order to bleed that pressure off safely so I don't have an issue when I disconnect this hose. So next up, I need to locate the low pressure fuel hose and find where that quick release is. Generally, that's going to be near the fuel rail. On this particular car, the intake manifold's on the firewall or bulkhead side, and I see my fuel pipe here. Pretty hard to see because of this air intake. We're going to go ahead and take that off so we can get better access. So I'm down to the last connection point on this air intake tube. I wanted to show a special tool that's really handy. If you have a tension clamp, like on this air intake tube or what we commonly find on a lot of vacuum and or coolant connections, this tool is great. Much better than trying to use some pair of pliers or channel locks to undo these. It's got a specialty fitting to help grab that. It's also locking so that I can squeeze it, it ratchets on, holds the tension until I pop the lever. Very handy tool. So now I can see the type of fitting that I've got. And so this one's got small tabs of metal on the inside diameter of this part of the fitting that I've got to use a special tool to depress them. And that's going to help me separate this so I can get it apart and then look at my options to add my fuel pressure gauge. Quick release fittings like this take a special tool to disengage them. If you can't see what looks like a small button on them, you probably need a set like this. This little scissor style works on a lot of things, but for this Toyota, we actually need a separate tool. This little green tool right here is made with a much thinner wall, and you can see it's got a taper and a step to it, and that's what we need for this Toyota. So I'm going to place this right there up against the quick release. When I push this in, I should feel somewhat of a spring kind of tension. When I feel that, that means I've engaged the tabs. I can slide this back and then release it. If I did everything right depressurizing the system, it should be pretty dry like this. I shouldn't experience any fluid spraying out. It is normal that this will have gas in it and it may drip a little bit, so I need to be cautious about where that could end up. With my line removed, now I can look for a fitting that's going to work. This is one of the fittings out of the SnapOn kit. What I'm looking for is the outer dimension or outer diameter of this piece here to match that of what's on my fuel rail. And so I can do this just visually. I could set it up and look for, does it appear to match? This one does. I could go as far as to use a caliper to measure this. These are often also cross-referenced with the part number for a diameter on the kit. This one appears to fit well there. The other check is I can take my line, make sure that it fits well within the O-ring of the line here, that it snaps in and will not pull back out. I always want to check for that physical tension to know that pressure cannot shoot this out and cause a leak. So now that I got this one selected, I'm going to follow it up with this other piece. This should match the diameter that's within this hose here. I'm going to make sure that that fits onto my rail, it snaps, and I can't pull it back off. And so now I've left with these two connection points that are going to connect to my hose where my gauge will also get hooked up. So my next step is I'm going to add this hose here. This has specialty connections that will go to the adapters that we've placed on the vehicle. They'll connect here with this snap system. I've got to unload these clips to get them ready to accept something new. Right? And so this little flap opens, whole thing pops up like this. So that little clip opens and then the whole thing moves that way. So when it's locked, it's down. When it's unlocked, I've got to get it pressed up like that. I've got to do this gently. These things break relatively easy. This one's missing a small piece already. So now I can take each end of this, make sure it's engaged all the way, snap my retaining clip in. I'm going to repeat the same thing on this line. Again, I always want to give a little tug back, make sure that it's locked in and that pressure cannot push it off. With my gauge set up now, I got to make sure that this little valve is open. Not all kits have this valve, but if I've got one, I want to make sure that it is in parallel with the flow through the tube or through the hose, right? And so this is the off position, in parallel with the hose would be on. Next, I can take my quick release fitting here that connects to my adapter. That hose travels through here and gives me a gauge, right? And this will give me my reading. Next, I'm going to go ahead and pressurize the system. We've put the fuse back in. We're going to crank the engine or key on for prime, check for leaks, make sure that my equipment and my connections are leak-free. Then we can carry out our tests. All right, so we were able to key on and prime the fuel pump. We see that we're holding just over 40 PSI worth of pressure. All of my setup looks good. I don't have any leaks. And so now I can put the air tube back on, run the engine, and do any of the testing that I need to do in terms of reading my fuel pressure. That's the process to set up and check for fuel pressure using a fuel pressure test kit like this one. Regardless of the brand that we're working with, whether it be the SnapOn kit like this, an OTC, a Matco, they're all very similar. They're all going to have to interact with similar connections as well on the vehicle. So make sure that you always depressurize the system first, regardless of the kit you use. Pull a fuse, a relay, use a scan tool, or maybe just even unplug the fuel pump. Whatever's easiest for your particular car is the way to go. Once we get that set up, again, always make sure you're checking for leaks. Before you run the engine, before things become hot, leak check your setup. Make sure you don't have liquid gas going all over the engine. The last thing we should talk about is why might I do a test like this? There's a variety of engine performance tests where I might arrive at fuel pressure from really basic concerns of just having no fuel pressure, like for a crank no start, up to performance related issues where maybe I'm concerned about the fuel pump's ability to provide fuel. This type of kit does not do a great job at measuring volume, but there are other kits out there that will give you volume measurements, and they have similar setup procedures like this. The last thing I want to leave you with is when we go to take this gauge off and take all of the parts and pieces back to restore the vehicle, we also want to be concerned about relieving fuel pressure. This gauge has got a small button. I could put a small hose on this, put it into a catch can of some kind, and when I push that button, it's going to release the pressure that's in the gauge and in the hoses so that I'll be safe to take it back apart. Again, no risk that I'm going to spray fuel on myself or on the hot engine.